Okay, geniuses, time to get your thinking caps on. Today we're going to learn a new skill. During this next quarter, we're going to be working on a topic called stoichiometry. And one of the basic skills that you need to know is how to decode the chemical formulas of compounds. That is, how to count the number of atoms of each element that make up a chemical formula. Chemical formulas show you the ratio of the atoms in a compound. And today we're going to count them. Some things that you want to make sure that you have handy. One is a periodic table and this assignment. In this assignment we're going to go through three different parts of the chemical formulas. One is something called subscripts, something else called parentheses, and on the back we'll go over coefficients. Then there are some questions, 3 questions and 15 problems for you to do, to work out on separate paper and staple to this page. Sounds like it's a lot of work, but once you get the hang of it, it's really quite easy, and we'll be doing it on a daily basis during this coming up quarter. So, don't let your mind wander. See if you can stay with me, and everything's going to be just fine. First, let's take a look at the periodic table of the elements. What I want you to notice about them is that each element has a capital letter at the beginning. Some elements, like copper, have a capital letter followed by a lowercase letter. If you want to tell the difference between one element and the next element in a chemical formula, look for the capital letters. It's just like how sentences start with capital letters. Element symbols start with capital letters. You can also find the names of these elements if you look really close. Let's focus up on, let's pick the V. If you look really close at the periodic table, you'll see the name of the element. This one is vanadium, and down here is barium. That's what you do with dead chemists. And right over here is my favorite one. This is what I'm doing right now. I'm boring on boron. That's what chemists do. So if you need to know the name of an element, please consult your periodic table. The first set of examples I'm going to do is to look at the meaning of subscripts. Subscripts are part of chemical formulas. Subscripts are just little numbers. These are examples of subscripts. Subscripts count how many atoms there are of something that they're hanging on. So this 2, for example, is hanging on the hydrogen. This 4 is hanging on the oxygen. Notice there's no subscript hanging on this sulfur. That's because there's just one sulfur. If you want to count just one of something, you just put the element symbol there. If you want to say there's more than one, then you have to put a subscript there. If I were counting how many atoms of each element there were, what I could do is list the elements, hydrogen, sulfur, and oxygen, and then the subscript 2 says there are 2 hydrogens. There is no subscript for the sulfur, that means there's just one sulfur. And there's a subscript of 4 for the oxygen, so that means there's 4 oxygens. How easy is that? If you want to write the names of these elements, just find their symbols on the periodic table, and then you can write the names next to them. Here's another example of subscripts. This compound is ammonium chloride. It's the one that's commonly found in those ice packs. When you break the ice pack, ammonium chloride dissolves and it gets cold. The elements are nitrogen, hydrogen, and this is chlorine. It's a capital C and a lowercase l. It looks kind of like an I, and you have to get used to that because most computer fonts, capital I's look like lowercase l's. I want to count how many atoms of each element there are. If I list the elements, nitrogen, hydrogen, and chlorine, and then I'll look to see what subscripts they have. There's no subscript on this nitrogen. That means there's just one of them. There's a subscript of 4 on the hydrogen. That means there's 4 of them. And there's no subscript on the chlorine. That means there's just one of them. Remember that subscripts only count the number of atoms that they're hanging from. That 4 does not count anything about the nitrogen. It doesn't count anything about the chlorine. It just counts the element that it's hanging on. Next example. This is cobalt carbonate. I use this one because I want you to see that sometimes you have to be really careful about lowercase and uppercase letters. If I list the elements in this compound, the first one is cobalt, and the next one is carbon, and the next one is oxygen. Element symbols always start with a capital letter. So this is one element symbol. Here's another one, and here's another one. The cobalt doesn't have any element, it doesn't have any subscript hanging on it, so that means there's just one. The carbon doesn't have any subscript hanging on it, so there's just one of those. And the oxygen has a subscript of 3 hanging on it, so there are 3 of those. Subscripts are the easiest part of decoding chemical formulas. Another part of a chemical formula is parentheses. These guys right here. They work in chemistry the same way they work in your math class, which is you distribute something from outside the parentheses into the parentheses by multiplication. But we're going to look at it a different way first. What you want to do is look at the subscript that's outside of the parentheses. This subscript means this is how many of everything you have in the parentheses. So this 2 says that I have OH one time and OH another time. 2 of them, 2 OHs. And then over here I also have calcium. So if I wanted to count my elements, I could list the calcium and the oxygen and the hydrogen. There's 1 calcium here. Together there are 2 oxygens, and together there are 2 hydrogens. 1 calcium, 2 oxygens, 2 hydrogens. Another way I could do that is to take this 2 and distribute it into the parentheses. 2 times 1 and 2 times 1. The subscript outside the parentheses counts how many things you have that are in the parentheses. Here's another example. This is magnesium nitrate. The 2 outside the parentheses says that I've got 2 of everything that's in the parentheses. So I've got NO3 in the parentheses. And I have 2 of them. So I could write another one. NO3, NO3. And I also have magnesium. I have 1 magnesium. I have 2 nitrogens. I can add them up like that and get 2. Or I could take the 2 and distribute it into the parentheses and say I've got 2 times however many nitrogens there are in there. The coefficient on this nitrogen is just a 1. The subscript is just a 1. So 2 times 1 is 2 nitrogens. Inside the parentheses I have 3 oxygens. 2 times 3 is 6. If I were to add these together I'd get 6 the same way. One more. This is zinc phosphate. If I count up how many things I have in the parentheses, the subscript says I've got 2 of whatever I have in the parentheses. So 2 PO4s. Those are phosphates. I've got 2 of them, whatever they are. And I've got over here 3 zincs. So if I count my zincs, I've got 3. If I were to count my phosphorus, that's the P, I've got 2. If I were to count my oxygens, I have 8. Now I could also take this 2 and distribute it into the parentheses and get the same result. 2 times 4 oxygens is 8 oxygens. 2 times 1 phosphorus is 2 phosphoruses. So the subscript that's outside the parentheses distributes to the subscripts that are inside the parentheses the same way as you do that in your math class. This is not as hard. The 2 does not distribute across the parentheses to that 3. It's not 2 times 3 zincs. Also, make sure not to add these 2. I wouldn't say that I had 2 plus 4 oxygens. It's 2 times 4. There's one more component to chemical formulas. That's called a coefficient. This is a coefficient. It's a number that multiplies everything that you have in the chemical formula. So if I say here that I've got 2 H2Os, that means I have 2 water molecules. That means I have H2O, H2O. 2 of them. So if I were to add up all my hydrogens, I've got 2 hydrogens plus 2 hydrogens, that's 4 hydrogens. If I were to add up all my oxygens, I'd have 2 oxygens. Now I could have also just distributed the same way that you do in your math class. 2 times 2 hydrogens is 4 hydrogens, and 2 times 1 oxygen is 2 oxygens. So it works the same way. Here's another example. This is aluminum hydroxide, found in some antacid tablets like Rolaids. Now, we've got a couple things going on. We've got a coefficient of 3, which means I've got 3 of this whole thing. Boom, boom, boom. I've got 3 of them. I have aluminum hydroxide one time. I have aluminum hydroxide another time. I have aluminum hydroxide a third time. So I've got 3 of them. So this 3 counts 1, 2, 3 of that compound. Now the other thing I have going on is this subscript out here, which says I've got 3 of everything that's inside the parentheses. So that means that I could break all of these out and say I've got OH, 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 OH. Oh, look at all that. I've got 3 aluminums. How many oxygens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oxygen equals 9. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9. And hydrogen equals 9 also. Now that's a lot of work. I could have just saved a lot of time if I'd just distributed 3 hydrogens, but I've got 3 times that many. So if I have 3 hydrogens and I've got 3 times 3, that's 9 hydrogens. If I've got 3 oxygens, but I have 3 times 3 oxygens, then I would have 9 oxygens. And if I have 1 aluminum here, but I've got 3 aluminums, then I've got 3. You can write it all the way out if that helps you, or you can try to do it like you do it in your math class. What I'm asking you to do is to think about how subscripts work, how parentheses work, and how coefficients work, using the examples that we just looked at. There are 3 questions. I'm asking you to write about how you would explain to somebody the way subscripts work, how parentheses would work, and how coefficients would work, and then to work on these problems. Write the formula. You don't have to write the name, but write everything that you see. Make sure not to miss any coefficients if there are coefficients in front, like these. Write the coefficient and the formula, and then list the elements that are in the compound and count how many atoms of each element there are. Use your periodic table to write the names of the elements next to them, the way that you see in the examples that I did on the papers here. Write the formula, write what it really means, and then list the elements with their names, their symbols, and count how many atoms there are of each one.